There will be many, many questions and discussion topics all together. So we are really excited to have you.
Perfect.
Good day, everyone. Great to have you here. We will wait one more minute to get everyone in. We have a really fantastic speaker today, Ilana Wisby, CEO and founder of Oxford Quantum Circuits. And in 1 minute, we will really start. Great to see all familiar faces again. Colleen, Vladislav, Stana, Julia. Wonderful to see you there. And it is wonderful to see all global quantum projects already coming up. And also many messages on LinkedIn, sharing insights, sharing experiences, encouraging other people to watch the YouTube recordings or even to sign up, although then there is a lot to catch up with. Today is all about superconducting quantum computing with even 5 excellent speakers. We will start with Ilana Wisby, the CEO and founder of Oxford Quantum Circuits. Very excited for her talk and session, of which science can be part, entrepreneurship, diversity. Feel free to ask questions about everything. In 1 hour, we will dive into superconducting quantum computing with Kyle Cerniak from MIT Lincoln Lab. And he will give a lecture guided by the DiVincenzo criteria to really give you good insight in superconducting circuits. And then we conclude with a lab tour at IQM, where we will see the insights of a superconducting quantum computer with a Q&A session with 3 of their researchers. A shout out to many people who have been sharing insights and also their scholarship appointments on LinkedIn. Several people have been tagging us, through which it was visible, spreading the word. Thank you for that. And also many people started the Global Quantum Project and have been sharing about that on LinkedIn and Discord. Wonderful to see. I would like to give a warm welcome to Ilana Wisby, physicist and entrepreneur, CEO and founder of Oxford Quantum Circuits. Oxford Quantum Circuits is a very successful quantum computing company in the UK, the first and only quantum computing company from Europe that is available on Amazon Braket with their superconducting quantum processor, Lucy. And Ilana has a physics background, but very strong entrepreneurial skills that has led her to this position, but also being a member of the World Economic Forum's Future Council on Quantum. She champions women in technology and leadership, is a Schmidt Futures 2023 International Strategy Forum Fellow, and an advisor to MPL's Quantum Metrology Institute. We are really excited to have you, Ilana. Please take it away.
Fabulous. Thank you so much for having me. I really appreciate it. And when you read through all of those things, I'm like, how do I have time to do anything? But somehow we juggle it all, huh? Yeah, so hi everyone, my name is Ilana. I'm a deep tech entrepreneur and of course the CEO of OQC. Really privileged to have the opportunity to share a little bit more about myself, my journey, and the company with you. I'll run through just a broad company introduction because I think quite a lot has happened in the last year. We've been really busy delivering on our incredible vision to put quantum in the hands of humanity and build this brighter future for everyone that is enabled by quantum. So there's big updates on both our strategy and towards that across both our commercial and technology that I'll be excited to share with you. Some of it actually I haven't shared publicly before, so that's quite exciting, and my comms and marketing team will be sat quivering in their boots as I've shared these, as I run through these slides, but it will be fine. And then we'll have plenty of time at the end as well for Q&A. So if anybody has any questions, I will always try to be as open and transparent as possible in answering those for you. So without further ado, let's crack on. I think best place to start is maybe a little bit about my background and my journey here before we run through into the company. So originally, I did a PhD in quantum physics. Actually, even before that, I did physics with a minor in music, which was fantastic fun. And then went straight into my PhD with at the National Physical Laboratory in Teddington, which was placed in industry. I was doing superconducting circuits coupled to rare earth ions. Was really privileged when I was there to have a load of experience with international collaborations. So I was collaborating particularly with Chalmers University and got to spend time in the incredible clean room facilities fabricating over there. After I finished my PhD, I recognized that it wasn't necessarily the right environment for me, and I much preferred and found a lot more synergy within the world of entrepreneurship. So what I loved about academia was being able to ideate, being able to take something all the way from concept through to, owning a project through to delivery. But I found sometimes it was a bit slow. I found that a bit frustrating, and also the distance to the real world impact. And then when I found entrepreneurship, I found, hey, everything I loved about academia transfers across into entrepreneurship, but also you can have like a closer experience to the customers, and there's this incredible energy, incredible culture that I really resonated with. So after my PhD, I did a startup that was doing diabetic retinopathy. We were creating machine learning algorithms based on photographs of eyes. And then we were deploying through a cloud system so that we could help support remote communities in diagnosing early onset diabetes through this diabetic retinopathy mechanism. I was then headhunted by Oxford Sciences, which is a fantastic investor in the University of Oxford, or sat beside the University of Oxford. And I knew our academic founder, Peter Leek, from my PhD. I have a huge amount of respect for him and his work. And when Oxford Sciences approached me about joining up with Peter to be the CEO of OQC, it was really an opportunity that I could not turn down. So I very naively said yes. That was 5.5 years ago, and really have taken the company from, the initial days of, Peter in the lab with this patent, proving out the technology at the university, all the way through to where we are today. We have now a team of 96, 97 incredible people. We are delivering and deploying quantum systems across the world, and really commercializing this technology, as well, of course, as building greater and bigger systems. And it's been an incredible journey for me personally, both in terms of leadership. And so right now I'd say, I'm not a quantum engineer anymore. If I'm in the lab, there's something that's really gone wrong and I shouldn't be. I have incredible, talented quantum engineers doing the day-to-day. For now, my passion is all about leadership. And really delivering and leading the company on this incredible vision and mission that we have. So what's that vision and mission? It's putting quantum into the hands of humanity to solve the world's most challenging problems. And we deliver on that through a number of different services with OQC Live. That's very much focused on overcoming the barrier to access and delivering those systems so that people can access them through OQC Live, and helping customers to solve the world's most challenging problems through OQC Labs. With this, we also handhold customers, we do POCs and help them on their quantum journey, and we can do a number of different contracts in that way as well. We know, of course, that the impact of quantum is going to be significant. It's going to be pretty much touching on every single market vertical out there. Imagine a world where you're no longer limited to pharmaceutical industry applications in the lab. You can start to do that through computation, again, finance industry as well, through optimization. But we see a huge amount of engagement across pretty much every single market vertical out there. And that's from national security and defense. So we work very closely with a number of governments. Obviously, I can't really talk about those, but financial services, we've got customers there. We've also got customers in energy and climate, running simulations on new types of materials, for example, health and life sciences, and also, interestingly, automotive and logistics. So we've got customers and partnerships across all of these different areas. And all, of course, driven from a commercial perspective of being able to provide quantum compute as a service to the mass market. So that quantum computing for all really does target mass market. We want to get it in the hands of humanity. And we're doing that with enterprise-ready quantum, ERQ. So our vision to deliver on this is it's got to be seamless, it's got to be accessible, it's got to be powerful. I know this is a schematic, but I will show you what that practically looks like in a moment. But seamless access, right? Let's get rid of queues. I don't want people sat waiting to be able to run a quantum algorithm. We're getting rid of queues, they're 24/7, you spin up a QPU, you do hybrid applications accessibly inside the existing secure infrastructure. So customers, typically they have data, it's very sensitive, and effectively want a computer on-prem. That underpins a lot of our strategy and our work. And of course, they've got to be powerful. That all sits, of course, with the processor itself, making sure that we're delivering high quality systems, not just at the quantum level, but in terms of the full stack of interaction. Now, OQC, our core IP, where we span out from the University of Oxford, sits with the coaxmon. So the coaxmon is a superconducting quantum bit, still built off transmon technology, but instead of having everything as a traditional transmon would in one plane, what we have is redesign that transmon into a completely 3D infrastructure. So taking it out of the 2D into the 3D. This is just a quick schematic of what this looks like. So on one side of the chip, we have our qubit, which is circular in geometry. So you have an inner and an outer ring out of a superconducting metal that sits on a substrate, usually either silicon or sapphire. On the other side of that substrate, we then have our readout resonator, which is also circular in geometry, which is also mode matched very carefully to the actual qubit itself. So then what we can do is bring our control and our readout either side without ever physically touching the actual processor chip itself or connecting in that way. We can control completely in this 3D plane and read out that qubit. So that's really the unit cell that we have. Actually, we don't even have to have wires anymore, but it kind of shows that it's easy to have it. There's a ton of advantages to this, but you can take the unit cell, scale it into larger and larger processors without having to have any complexity in your fabrication. So no need for air bridges, through silicon vias, flip chips, anything like that. So this is what makes OQC so special and so different, as in really been the core to enabling our rapid delivery of end-to-end systems, but also our vision for how we build 10,000 plus qubits from this core coaxmon infrastructure. Now, we've delivered Lucy. Lucy's been available on Amazon Web Services for around 18 months now. And that's basically you can log on to AWS Bracket and you can access OQC's quantum computer anywhere right now from 10 until 1. Now, one of the launches we had last week is for dynamic scheduling, which is the next step towards getting rid of those specific windows and enabling 24/7 access to quantum. So that's a huge step. We've got phenomenal reliability, great uptime, 98.2%, which has reliably been serving customers all around the world with access to this system. This system is in our lab in where I am now, just outside of Reading, and connects to the public cloud. We also have private cloud access, so customers can log on and run algorithms, and we can support them directly through private contracts. What that practically looks like is this. So this is our lab in Reading, and you can see my CTO there, Simon, and one of my lead engineers, John, there. And this is our lab here in Oxford, here in Reading. And it's great, right? It's a phenomenal space. We were so excited when we moved out of the R&D environment into this facility, but it's not enterprise-ready quantum. Like, for context, Reading had a power cut at the weekend, and we had to make sure we've got all of these systems set up so the alarms kind of go off, people get notified. But we don't have backup power, we don't have generators, we don't have all of the infrastructure that you would require to meet commercial TRL readiness. So poor Brian, one of our other quantum engineers, jumped in his car and made sure that we came in, turned the compressors back on, and kept Lucy running. So that's an example of where this is phenomenal, but it's not quite enterprise ready. Now, what enterprise ready then looks like is this. So this is our next generation system. For those eagle eyes, you'll recognize that this is still being installed when this photo was taken. But this is a system, a real 32 qubit processor system being installed in a data center. And this is in Tokyo. And this is what enterprise ready quantum looks like. Quantum computers in data centers where customers already are as part of their existing infrastructure. They have, I cannot communicate to you what a room full of batteries look like, but they have rooms full of power, full of backup generators. This is part of the national infrastructure. That is what enterprise-ready quantum looks like, where customers can seamlessly log on and access this as part of their secure data infrastructure and environment. And what we're doing here is delivering Toshiko. Toshiko is our next generation system. It's a 32-qubit processor. All of these systems, we've got one deploying in Tokyo, we've got systems in the UK, we've also got systems in Spain. We've got a huge increase in our feature set on our software as well. And we're currently tuning up these processors. Some of them are already available through private access, but we're super excited to be publicly launching them around November of this year, some of them a little bit before. So how we do that is through Equinix. We partner with data centers, and we have this incredible partnership with Equinix, which most people probably haven't heard of, but really it's basically like the world's internet. It underpins the world's infrastructure of how people access and communicate and run computation. It's got 10,000 plus global customers. It's got this huge fabric network. Like, this is the world's #1 data center. And that is just phenomenal. And it's through Equinix that we have this partnership with, where we've deployed Toshiko, our next generation system, into an Equinix data center that will enable access through all of those customers, which is, it's really just phenomenal. We've also, one big announcement that was from a few months ago is with Fujitsu. So we have a really great partnership and relationship with Fujitsu. And through this, we're delivering high performance compute. So you've got a quantum computer with a high performance compute layer integrated into Sesca in Galicia in Spain, which is, again, the future of quantum, of hybrid classical compute through these types of partnerships. And that's a really nice quote from Vivek at Fujitsu. Now, the team, my favorite part is the team and leading the team. And at OQC, we've been very passionate about making sure that we build a quantum future that is, you know, really diverse, is ethical, and really reflects the world that we want to see and build. Today we have 96 people. It's changing every week. So I think it might even be 97. A large proportion of those, of course, sit within our engineering capability. So it's 70% R&D, 30 plus PhDs, 25 actually nationalities represented across OQC. Right now, it's around 30% in terms of race and ethnicity representation, which is not good enough, but unfortunately is still significantly above the national average here, and 50-50 gender balance in the executive team. We're very passionate, of course, about sustainability. So we're really trying to make sure that both the applications that we're developing, but also as a company, we're working in a way towards a sustainable future. And actually, there's quite a number of underlying work programs we have about how we're tracing our supply chain, about how we're making sure that the power utilization and the systems we're building are ethical and sustainable in terms of our delivery here. We also speak and engage a lot in terms of thought leadership around ethics in quantum. We recognize that, you know, just because it's well intended doesn't mean it's going to be well applied, and making sure that we have and pioneer these types of difficult conversations as an industry leader is something that's very close to our heart. So being very mindful about, you know, what we are doing here, and both the good and the bad that can be used for, and making sure that we're engaging both on policy and governments as well as an ecosystem in terms of ethics in quantum. And of course, very, very passionate also about diversity and inclusion. So we have over 26 internal D&I different mechanisms, which both support, you know, team members in terms of inclusion, but also around the talent pool and the pipeline. So there's quite a number of underlying activities there that we have to support, be it from, you know, the simple stuff like making sure that the job specs that go out are truly actually more gender balanced in terms of female, because that actually helps attract more women in terms of applications. And by the way, it's like, I think 8% PhDs, and even now we have, like, it's really a small percentage of applications, even with all of these type of activities that come through from women. So this is an area in particular that I want to make sure that we focus on. Across the company, we provide significant training around leadership, particularly for our women, as an incredible program called Upfront that I would highly recommend, by a lady called Lauren Curry, which is all about inspiring women confidence. But a lot of this also sits within our values and who we are as a company. And at OQC, we lead with love. And I think that's something that is maybe a little different for a deep tech quantum computing company, but I think is also as integral to our success as the coaxmon is our culture and our people and our leadership principles. With that, I think that's a plenty of hopefully things for you to touch on, and I'm more than happy to take questions on any of the areas that I've tipped the iceberg with, but hopefully that gives you some insight into who I am, who we are, and some of the things that we'd be happy to discuss today.
Thank you, Ilana. This was really phenomenal, really inspiring, including your own story and the vision of the company. There are many, many questions already on the Discord, and Rayssa and Madalina, our great hardware team members, are joining me for the Q&A.
Awesome.
I would like to ask a first question. I already saw some small letters on the slide, namely about both quantum computers, that they have female names. Whom are they named after? What is the reason?
Yeah, I think thank you for asking that question. I should have pointed that out. So yeah, all of our systems are named after pioneering women in science. So the first system, Lucy, is named after Lucy Mensing, who is a German physicist and quantum mechanics pioneer. This was really topical because Lucy was Europe's first quantum compute as a service available on Amazon Web Services. There is now an additional system as well through AWS, but that was really important for us to represent like that European piece. And yeah, we're very passionate about Europe still as well. And we also have offices in Spain. So European interactions, we very much see ourselves as a European company. We want to celebrate a European scientist with that. With Toshiko, this is the first system that was deployed into Japan. So Toshiko is named after a lady called Toshiko Yuasa, who is I'm sure that Japan had many female physicists, but this was the first recognized female physicist in terms of a doctoral program. She spent most of her career actually in Paris. But yeah, we're trying to help promote the stories and also reflect the company with the names of our systems being named after pioneering women in STEM.
That is really fantastic. And I would like to see some hands of people who knew Lucy Mensing before, compared with
I see not
real pioneers. Indeed, usually everyone says it right away. Before going to you, Madalina, I will also ask a question from Taha Bouraba, a very successful quantum physicist in Algeria. He asked, how was it for you to move to the CEO position as a physicist? Are you still, to which extent do you still hear about the lab developments? To which extent are you involved? How is it to be more hands-off?
Look, the journey of a CEO, especially from early startup to where we are today, it's continual personal growth, right? You have to grow really rapidly. And for me, it's all about growth mindset, like embracing coaching, but also coaching others. So yeah, it's been a journey and it's been one of the most rewarding things, but I'm definitely no longer, in the technology. If I am, there's something that's gone wrong. However, I would say having the PhD in my background was super important in the first few years. And of course, when I'm still speaking to, the board, with investors, with my CTO, with the team, it's really fun, really a huge asset that I can keep up and that I can still keep in touch with the technology, can understand what's being said, can ask the right questions, but also have that perspective of being the intercommunicator, right, between the deep technologists and then be it the outside world, whether that's, whatever stakeholder that is, if that's the investor, a chairperson, a customer, to be able to be that interface and to try to understand and apply a lot of emotional intelligence about what is the message that's actually trying to be asked here, because often people don't necessarily know the questions that they have something in their mind, but they don't really know the questions to ask to feed them out. So I'd say it's been a journey. It's been incredibly rewarding. It is incredibly difficult. My role now is in leadership. and not in the science, but I trust and empower our incredible team of technologists and our leads and our CTO with that. My favorite part of every month is my CEO report month, which basically I get the full reports from all of our tech leads on all the different areas and all the different projects that are happening. And that's really fun because then I do still get to keep in touch in that way in terms of the actual technology. And of course, when you get to then show people the lab, like that's always super rewarding because, you know, you just see their like faces light up when they see this type of technology and being able to help communicate and translate that.
Phenomenal. The next question for Madalina, who is also in the UK. She is a trapped ion PhD researcher nearby. Please unmute Madalina for the next question.
Of course, the next question. First of all, thank you so much for the talk. It's always interesting to hear about everything that's happening in quantum. So the next question is from Mohammed. I apologize if I mispronounce name. As an entrepreneur, what do you think would be the future of superconducting quantum computing in 10 years' time?
So can you just ask that question one more time? What was the feature of superconducting in 10 years' time?
The future. The future, yeah.
Yeah, so this is really where we're building that enterprise-ready quantum. So we have systems deployed in data centers. I don't think they'll look like the systems that we have today in that right now they're kind of, everyone will have seen the pictures of like the chandeliers. I don't think it will look like that. We do have some work programs with our partners on what that future looks like from a cryogenics perspective. And ultimately, this has all got to be compatible with enterprise-ready quantum in data centers. So I imagine more like some sort of interconnected rack of some kind that, of course, will likely still require the cooling mechanisms. For us, with the coaxmon, we can get many thousands of qubits into the same space, which is a huge advantage. So I don't think they're going to be the size of football pitches. I know we've got this simulated and mapped out that it's more likely to be more like a room size, but it's got to be able to be a room that sits within the data center with tens of thousands of qubits in it. I think that future is still hybrid. And by that, I mean, it's classical quantum, right? I don't think that everybody's going to be running algorithms solely on quantum computers. You'll need super low latency connections, edge-to-edge compute with GPUs, CPUs, QPUs. And I also think that there'll be a lot more partnerships across the stack. So this is also what we're building out, partnerships with people like NVIDIA, like quantum software companies. So I think there's going to be a lot of movement still within the actual infrastructure and the stack itself to how we deploy and develop and deliver customers' systems themselves. I do think it is not on-prem, right? People sometimes say, I want to buy a quantum computer. I don't think customers should be buying quantum computers unless they're governments, really. I think it will be QCAS, like quantum compute as a service, and I think it will be seamlessly integrated into existing infrastructure. I still think there'll be transmons. I do think there'll be the coaxmon. I would love for the coaxmon to be underpinning all of the different companies' IP in some way. That would be fun. But I am massively biased in saying that.
Thank you very much. And probably like as a continuation to that, how geometry modification can help us achieve large-scale superconducting systems?
Sorry, my line went again. What was the beginning?
How can geometry modification help us large-scale superconducting quantum systems?
So some of the geometry modifications in terms of the actual processor itself for OQC, I wish I had a board. I don't. If you imagine a typical transmon, what you have is this kind of meandering inductor that's like a long, like snake type element, and then you'll have a long snake type element for your capacitor. So you've got this LC resonator, and then what you'll have is all of your geometry of your lines coming all the way through for your microwave control. You'll then have readout components, and then you'll have some sort of coupler between the different qubits to enable different connectivities and connections. And they can either be tunable or they can be static. So there's a load of flexibility around what that physical practical infrastructure looks like, right? So there's lots of different designs that you can build. what we've done is, instead of making a physical change to the geometry of that transmon itself, we've simplified it and made it as simple as possible. And that means that what you can then do is have a ton more flexibility around what you do with that system. You're not limited to sort of the physical space that you have. So I think the flexibility that's afforded by simpler geometries is going to be very powerful. What we're already seeing in terms of geometries, say for IBM, they've got lots of through silicon vias. They've built this kind of stack, which enables them to have all of those different components in a 3D system. So I think geometry-wide, everyone recognizes you can't do this in 2D for superconducting circuits. You do need to move to 3D. And they are finding different ways to do that, be it through stacking and having different elements of your processor in individual layers, or be it 3D with the coaxmon, whereby you've got a very simple, elegant way of creating that same stack without a lot of the complexity. So 3D and simple are my summary answers there.
Okay, thank you very much.
I would like to switch it with an entrepreneurship question. Harsha Chenji from US asks, how easy is it to raise money for the company, also in these times where we don't really have a practical quantum advantage?
Yeah, it's a great question, right? Because we can't be naive to the fact that this stuff and hardware is expensive, right? So there's quite a high barrier to entry to be able to deliver on these systems. And ultimately, you know, when we're commercial, right, we're building businesses, we have to be commercial in mindset. And yes, of course, the investors, they care a lot about what we're doing. They care about the impact. They often want to leave a legacy, right? They're looking for the next big thing. And that's emotional in many ways, but it's also money, right? They've got, so the way it works is you have investors, and the investors have LPs, which means that the investors have investors, and it's the investors' job to invest on behalf of their LPs to get a return on investment for each fund of the actual LPs themselves. So there's multiple different drivers. And again, if you think about it from a lens of EQ, it's like you've got an individual personal driver, like I want to be successful in my personal career. I want to be able to leave a legacy and be involved in building an incredible company in the future of technology. And it's also, I need to be able to make money, and I want to be able to make a lot of money in doing so. So I think it's always good to have in mind those different things. And that does make it difficult. But that said, it is a phenomenal application. It is a phenomenal story. It captures the heart, the minds, the imaginations, because the market potential is so great and the impact is so great. That's hugely attractive to the investor community. On the other side, it's really hard to do any sort of diligence, right? If you've got an investor that feels like they want to understand quantum computing properly, like they'll need to have 5 PhDs. Like it's just not going to happen. So diligencing is really hard, and that's where you need to be able to, you know, work with experts, and they need to be able to be connected to experts and to have both a view on the technology and the credibility of the technology, but also the credibility of the team, the strategy, and the commercial. So I actually think to be an investor would be really, really hard, because you have to think of all these different things, but ultimately they just want to place bets in the right places with the right people and the right teams. If you have the right people and the right teams, they'll deliver the best on the technology and on the commercials. So it is hard. The markets right now are very difficult. And I will say that's a pressure I feel, you know, because my investors feel it. My investors feel it because their LPs feel it. So a lot of the LPs are, say, private equity firms or businesses that themselves have revenues, and they've seen their revenues. So they have impact in terms of their liquidity. And even if they've committed money to the investor fund doesn't necessarily want to ask them for the money at that point in time. So you end up with a bit of a strange cycle. And because of that, there's then extra pressure on the companies, because, you know, we've obviously got to raise money, and we've also got to deliver product for our customers, and our customers may be spending less in terms of their R&D budgets because of all the different pressures. So there are pressures. I would say deep technology is actually slightly less impact than someone like a SaaS model, where you are entirely dependent on revenues. So if I had a revenue target and the company's success is linked to bringing in, 2 million, ARR type KPIs, and suddenly that drops off, then I'm stressed. The kind of good thing about being in deep tech is that everybody's along the same lines, in that we're all aligned that this is a long-term bet before there's significant return on investment. Therefore, there's less pressure quarter to quarter on revenues. That's true for a private funded company like OQC. But it's not to say that we don't also experience that pressure.
Very insightful. Thank you. Rayssa Bruzaca, our hardware team lead, quantum optics physicist from Brazil, then Denmark, now at NKT Photonics, will ask the next question.
Yes, so nice to have you here, Ilana. So let's talk a bit about qubits. Naya from Iran, what was the limiting factor that prevented you from implementing more than 32 qubits?
Sorry, can you ask that one more time? My line is really bad.
Yes. So what was the limiting factor that prevented you from implementing more than 32 qubits?
What's the limiting factor?
Yes.
We can build many more hundreds of qubits. Will I get any more power from those systems today? No. Will it cost a ton more money? Yes. Right? So I understand IBM's strategy of building larger and bigger systems, pushing that infrastructure, but ultimately the most powerful systems, like as you're adding those qubits, if your performance and if your overall power is not increasing, like from my perspective, there's no point doing it. It's just a waste of money. If we had that money, we could do it. So that's like, from a strategic perspective, the answer to that. And we can build hundreds of qubits on a wafer today, but realistically, they're not going to be any good, right? They're not going to be giving me any more power than building 32 really good qubits, connecting them up smartly, optimizing my control stack. And then what we can do is iterate on those individual platforms, and then iterate on the 32 qubit platform, optimize across our 2 qubit fidelities, which is the key thing. So from a limiting factor, then on the next level of the technology, we need to make sure that we are delivering high quality processes and reducing our error rates. There's lots and lots of underlying R&D projects towards doing that. But ultimately, you need to have high coherence, high fidelity. We need to get to 99%, 99.9%, 5-10 years or so, right? Let's get there. That comes down to minimizing the loss mechanisms, building beautiful, high coherence, high performance, low error processes. And that's where we need to focus our attention. In order to do that, we need to make sure we've got the right facilities and infrastructure in place. And candidly, right now, we work with phenomenal clean rooms, but they're still in academia. And the fact that we can reproduce 200 microsecond, qubits on wafers at the wafer scale with like 2% variability in that environment is like wild to me. Our fabrication team is just fantastic, but we don't have full control of that environment. So one of the big things that we need to build and develop is also a clean room, so that we can have that ultimate control of the actual environment. And that will be when we raise our Series B, partly what we're looking to fund. And that will be the key unlocking for us to be able to feed into that R&D to build higher quality processes. We have this beautiful KPIs table, which has all of the different underlying technology metrics, right? From readout fidelity to 1 qubit gates, 2 qubit gates, like different quantum volume measurements, be it from different algorithmic suites, all of these different metrics. What we're then doing is tracking where the blocker is, right? So where on each of these is the underlying blocker of what we would need to optimize, that we're going to get the most gain in terms of the overall performance of the system, both at the processor, but also within the actual stack itself. And that's how we choose and prioritize and target our internal R&D. We also partner with people as well. So it's not public yet, but there's an announcement coming out in the next maybe 48 hours about another partnership with different quantum software companies, for example, that focus on optimization. And you can also get a lot more power, a lot higher quality by working with different people at different layers of the stack to reduce different error rates through different error correction, error detection mechanisms, which we partner with, but we also do internally as well.
Maybe just a follow-up question as well. So what will be the contribution of Fujitsu in the next hardware updates?
That's a great question. So our partnership with Fujitsu right now is limited to the physical project that we've got to deploy that system into the supercomputer center at Galicia. So as part of that project, Fujitsu are partly funding this sort of ecosystem environment and supporting that Galician quantum ecosystem. They're also providing the high performance compute layer. What we're then doing is providing the actual quantum computer itself. And there's a nice, beautiful kind of interaction where we have the high performance compute and the quantum coming together. So they're not physically working on our hardware, and we're not physically working on their software. Fujitsu do also have a fantastic team that do build quantum systems in Japan, and they do great work over there as well. So they're both a competitor as well as a collaborator, and I think that speaks really well to where we are at in terms of the ecosystem. We need to both compete and collaborate where it makes sense, and we shouldn't be afraid to do so. And I think that's a really good example of business and also competition and strategy and ecosystem all coming together, and those dynamics at play.
And this is wonderful to hear, Ilana, and quality over quantity, collaborating, not only competing. There are many, many more questions about leadership, about co-exmont, about ethics. Madalina, which one is the next question?
I will ask one maybe about a little bit more about the company. So Kumkum asked, does your team work on any industry projects, or does it only deal with the quantum hardware management?
That's a great question. So the slides that I can't put in here, but I would love to, are many of our customer projects. So I mentioned earlier that we do work across defense and security, automotive, as well as finance. We've got lots and lots of customer projects that our team do interact with directly. I can't share the details of them, but the way we typically do this is we will have some element. So we don't develop the algorithms ourselves, but we do have people that understand the algorithms and the applications across different market verticals. And then they can support and onboard through OQC labs, the customers. We often provide an exemplar, and then we help them to then optimize their algorithm application. So that's kind of how we interact at that level. So we do also, as well as the hardware, have a quantum software team. They work on the control software, but also like feature sets for our QCAS, because by delivering QCAS, we have to have a platform. It has to be secure, of course, so it's fully end-to-end penetration tested. And there's some really phenomenal user experience problems, for example, the dynamic scheduler, that are really heavily software focused. We also have our control hardware team. So we do build our bespoke FPGA control hardware in-house. And that, of course, also has firmware as well as design. We also have engineering teams. So lots of diverse talent across the company, not simply limited to quantum engineers. And what we typically find is everybody's learning from each other. So we'll have quantum engineers working with classical engineers and software engineers and very cross-functional teams to deliver on specific projects.
Then Yash from India is interested in what the future of hacking will look like. He asks on the topic of quantum hacking, what is your opinion on hacking a quantum computer, quantum hacking? What would that even be like, and what powers does it hold?
Great question. I love that. We sent, so last year, I hope I can remember the name, but there's this humongous hackathon, or not hackathon necessarily, but a humongous hacking convention in, it's really famous, but I can't remember what it's called. Basically, everybody goes there. It's hosted in Vegas and it happens around November. We went there last year and we put Lucy online. and we ran a hackathon, right? And it was like, okay, what's going to happen? Well, let's find out, right? And they were super, super engaged with the fact that we did that. Look, realistically, from a hackathon perspective of we bring together people, we've run hackathons with NQCC as well to solve problems and how you might utilize a quantum computer. There's also, of course, a risk of people hacking quantum computers themselves, which is why, of course, just through any type of industry, you need to be very careful about your cybersecurity, your penetration tests to solve that. But then it could also be a very powerful tool, of course, also for the future with these types of applications that feeds very much into ethics. And you have different types of hacking. Of course, you've got white hat, black hat type applications as well. So I think it will be very much, part of that world. And this is also why governments and nations are paying so much attention to it, because of both the opportunities, but also the challenges this new type of technology is going to create. And it's not simply a small tool, like it will be such a significant advantage to those that do have access. That was a fun question. Good question. I'm going to try to remember. I'll get my comms team to send it over so you can put it in the description of what it is, and you should attend the conference. It's so good.
Fantastic. Maybe some people will become ethical quantum hackers.
Oh yeah.
Over to you, Rayssa, for the next question.
Sure. Sorry. Yes, maybe could you tell a bit more, how do you hire people in your company and what things you consider before hiring anyone?
Sure. So in terms of recruitment, we have a recruitment process that we try to make as accessible to everyone in terms of that actual process itself. We typically advertise our roles. If you log on to OQC, you'll find the careers section. You'll see the roles that are available. And we also, once you're in, have a walkthrough, which clearly breaks down the process for you, so you understand the different stages of recruitment that we have. We obviously make sure our job adverts are inclusive in terms of the language that we use, but also in terms of the language used around feminine versus masculine, in terms of the language there, because it's also demonstrated that if you use certain language, you put people off. They then go through to a scoring matrix. So we anonymize the CVs and by that, it's the names, it's any sort of gender piece there, especially. We used to also do, though I'm not sure if this is still happening actively, the universities as well, but particularly in the early days where I didn't want there to be significant bias around the types of universities people went to help support a diverse and recruitment process. That then goes out and they are all scored. So you'll have the process, they're scored against these matrices. We then take them through the interview process. Of course, we make sure that we have and pull scripted questions. It's not to say that we sit there like this, like everyone's super friendly, super nice. It's as much of a two-way experience, right? We want to get to know you, but you want to get to know us. And genuinely, it should reflect who we are as an organization. But for fairness, we also do want to make sure that we are consistently asking the right questions. They will typically be more competency-based. And what we're really looking for is not only technical prowess, so there will always be a technical element to the interview process. Usually there is a technical test associated with that. And by technical test, if you're applying for a technology role, that will be bespoke and tuned by the hiring manager. If it's a role for, say, even REAs, we'd give them a test, right, to see how they're going to perform in that way. If there are challenges around you completing that test based on different neurodiversity or things you need to take in mind, please just let us know, and we'll make sure we adapt that to facilitate. And then, of course, we also try to make sure we have a diverse panel as possible through that process. Usually it's 4 interviews, and there's definitely always ends with a C-suite. So it's usually myself or my COO, Tony, as a final stage interview, which is 30 minutes. If you're there, you've pretty much got the job. Like, just going to spoil it there for you. That's really just a final hello and get to know you at that point in time. We also recruit, put postings on minority job boards. We run apprenticeships. We do also have the odd intern scheme. This will be something that we pick up further next year. We do a lot of sponsoring and mentoring of programs and groups as well, particularly around supporting diversity and minorities in tech.
Very good. maybe a question like, let's say that someone would like to become a CEO, right? And this person has finished the PhD or just starting the journey. What kind of advice would you give to this person, like from like the technical background to the CEO of a big company?
Yeah, I think part of me is like, if you want to be a CEO, you probably, it's like that sentence someone says, like, if they want to be prime minister, they probably shouldn't be prime minister. Like, if your dream is to be CEO, then maybe like I would just question a little bit as to what is driving that, right? Let's just first just check in with ourselves. What is driving that? For me, it's like, if your answer is, I want to be able to build something, right? I want to build and deliver something and support and inspire through servant-led leadership. And I love to lead. I love people. I want to build a company. Like, if that's the answer, like, go for it. If it's, I want to be a CEO because I think that's like more of an ego drive, then potentially just self-reflect a little bit. Not to say that that's the case, but sometimes it is. So I would always firstly just stop and recognize, what is it that I'm actually like looking for here? If you've done that deep thinking and you think the only way you can do what you want to do is by being a CEO, growth mindset, right? Find coaches. You need to read, you need to try to recognize that you will be needing to grow quicker than the company. Find incredible entrepreneurial books. Put your people first, really invest in people and culture and leadership principles. Find the books that work for you on those. For me, I love things like Leap. So for OQC, we lead with love, and love is central to everything we do. Very much of the mantra of do what you love in the service of people that love what you do. Love is just damn good business. And this is all the mantra of Steve Farber. So I'm very much a Farberist in that way. We've got Leap as one of his books. Also things like, for us, we lean a lot on Jocko Willenick. This is all about extreme ownership, extreme leadership. So he's got one book which is Extreme Ownership, another one which is The Dichotomy of Leadership. Both phenomenal books. They're business books that are framed entirely through the lens of leadership, entirely through the lens of storytelling, impact, and then applying it to business. So this is really where, I love those types of books, but find the books that work for you, do the investment, do the reading, and then find the support network that will help you through your personal development journey and grow. As a CEO of a fast-growing company, you do not have time to learn through experience alone. You cannot say, I cannot get wise through time, right? I need to learn from other people who have lived experience, who have made the mistakes. I will still make mistakes and I will learn from them too. But I want to be able to gather as much knowledge, as much insight, invest in leadership, invest in emotional intelligence, as the two primary things. And if you do that, I think you're probably on the right track. You don't need an MBA. Sorry.
Good.
I
do love an MBA, but don't necessarily need one.
Yeah, that is wonderful advice for everyone. And here on the WOMANIUM side, everyone is learning quantum, but we say everyone should be a teacher as well, a communicator as well, right away. Chevron Y asks, how can we communicate about quantum technologies better to people from different backgrounds, also without risking misinformation? What is your advice on communication?
Yeah, this is such a fantastic question. It's so important and it's really challenging. And I'm sure many of us here have heard the Joe Rogan podcast and have slowly cried ourselves to sleep with some of the things that were said. It is really challenging, right? Because what we need to be able to do is to communicate science and technology in a way which is accessible. And that means that sometimes it's more important to get the message or the principle across rather than necessarily the full deep science and technology. So there is a balance of always being completely scientifically correct and sitting there and getting stuck in the detail about, well, is it really exponential or is it a quadratic to the power 4 or whatever, like whatever you want to say. Like if you do that to an average person on the street, like the representative of the general population, they're going to look at you like you have 4 heads, and they're going to leave with 0 type of engagement or information or understanding. So we need to be able to find ways to communicate effectively, which balances scientific integrity and accuracy, but is also inspiring and through stories. So if we can find the stories, if we can find, and often when I say the word stories, maybe as a scientist, my inner scientist goes, oh, stories, that's fiction, that's made up, but it's not, right? They're ways of effectively communicating information in a relatable manner. So what type of analogies can we find, right? There's a reason that I and many other people, when describing fundamental quantum principles, talk about a coin with a head and a tail, and how we can spin it, and we can think about superposition in this way, how we can think about having 2 coins and how they can be entangled. And this is a relatable story that gets the principles across in a way that most people can understand. So I think finding those types of analogies, and I would love to have some new analogies and be able to tell new stories. I think that will be really powerful. So if you can think of different ways, we can do that. For example, the Google paper that was out a few months ago, I was asked for Radio 4 to go on and present and to talk about the paper. And I spent the night before trying to think about how on earth am I going to describe like randomized circuits and this type of deep technical paper. And I spoke to Jamie, one of our incredible quantum engineers, and he came up with this idea of a maze. If you have a maze and you're trying to be inserted into the maze, and you get a picture of where you are, and you come in and out, and by doing that you get a picture of the full maze. It's something that's relatable, that communicates the concept relatively accurately without having to use a lot of inaccessible scientific jargon that most people will just be turned off by and won't understand. So I think this is the thing that we need to understand. And I think empathy, again, EQ is so important. If, there is absolutely a place for publications, for peer-reviewed papers, that's 100% required. It's not necessarily required for the type of stories that you'd be telling in the paper. Like, people don't understand that. So we need to find a way of balancing those two things and not being angry. I see a lot of anger between the people who are trying to tell the stories and the people who are trying to tell the science. And actually, I'd like to see more collaboration and more recognition that everybody's trying to do this from a place of love, and let's work together to find out where that line sits. And it's up to us as scientists to be able to communicate that science effectively and to move, as well as for the journalists to be able to seek to understand, but we have to support them on that journey as well.
Again, collaboration, a key word.
Yeah.
To conclude, what are you most excited about for the next 10 years in quantum?
Of course, impact, right? I am so excited to wake up one day and to see on the front pages of Forbes or whatever it is that we have been able to deliver a real application, whether it's creating a new drug. But I'm particularly inspired actually by the material simulation side of things. So if we've been able to truly simulate something that was just currently intractable, that we didn't understand, but now we do, and that's been enabled by a quantum computer, I think like that's my life's mission. And eventually, of course, that might mean that we can help solve real human challenges, like work towards Alzheimer's, work towards new drug discoveries, work towards new energy materials for batteries. Like, these are the types of, if I go back to the previous point, stories that are based, you can link them back to scientific papers. They're inspiring and they're really true. So as long as we frame them, that's not something that's going to happen in the next few years, right? But that's the world that we can build towards. And there will be a step in the next 10 years where we've got these milestone checkpoints that we're taking those significant leaps towards that. And I think that will be, yeah, incredibly, incredibly rewarding. Past that point with OQC, like probably we're going to hopefully go public one day. And I think that will be a fun day for everyone, won't it?
Is there something you want to say to all participants or want to ask and to get the replies on Discord?
Oh, that's such a good question to throw at me. I guess like the challenge I would put out is entirely around communications, and the challenge I would put out is what can you do to play a part in bridging that gap? Can you put science communications out? How can you support and facilitate the collaboration and the communication of this technology to make it a success? Because we need to collaborate, we need to work together, we need to communicate. So my challenge to each of you is, what can you do from your expertise? And if you don't come from the quantum space, even better, what have I learned that I can relate to what I've learned through this program, and how can I communicate that onwards so that we can continue to build this ecosystem and create new stories and continue to create messages and play a part in it, because it's an ecosystem and it takes all of us. So don't underestimate your individual power and potential in building this. It requires community, it requires people, it requires communication. And I'd love to see someone give me something else that's not a coin spinning activity.
Great. The challenge is on, everyone, and we can do that right away in the Global Cleaning Project, the last project of this summer program. Ilana, thank you so much. This was really a wonderful session. You have inspired me, you have inspired the team, you have inspired everyone. It was great having you today, and we look forward to keep welcoming you back. And
thank you. Thank you so much. I really appreciate the time. Also check out OQC, keep in touch, follow us on LinkedIn, do all of the stuff like a YouTuber, but you know what I mean? Like, please do follow us, and we're always recruiting. We're in the UK, we're in Japan, we're in Spain, we're internationalizing. So if anybody is looking for an opportunity, please do keep us in mind. I'd be very grateful.
Thank you very much, Ilana.
Thank you. Ciao, enjoy the rest of your afternoon.
Great having you today.